Hi, my name is Patrick. I founded the company Algorithmica Technologies some 10 years ago to bring machine learning methods from mathematics into industrial application. And one of our products is the Intelligent Health Monitor, which makes sure whether your equipment, be it any technical equipment in a chemical plant, a power plant, petrochemical plant, is healthy or not. Now typically you take various measurements around a larger piece of equipment. You measure maybe temperatures and pressures and vibrations around there. And these measurements are meant to be within a certain interval. You have a minimal and a maximal limit to these measurements, usually given by the manufacturer of the device. So anything in this middle range is considered a healthy operational state for that piece of equipment. And as soon as it dips below the minimum or goes above the maximum, you have an unhealthy state and an alarm is released. Now we all know from experience that some alarms are released that actually don't mean the machine is in an unhealthy state, so they're false alarms. What also happens is that there are some unhealthy conditions of your piece of equipment that are not alarmed in this way. So this standard method of condition monitoring is not adequate to completely tell whether your piece of equipment is functioning properly or not. The idea that leads to a significant boost in performance is to allow these limits to be dynamic. So not fixed minimal and maximal limits, but allowing them to move with the flow of production as well. And the way that this is done is that a model is created for this measurement and a confidence level is placed around that model, and then we test, is the actual measurement within that confidence interval or not. If it is within the confidence interval, then we can agree your machine is working healthily, and if it isn't, then your machine is unhealthy and must get alarmed. Now, we can see from industrial practice and experience that this method allows for fewer false alarms, so you don't get as many alarms coming out of the system that actually don't have an underlying unhealthy cause. And also, it points out all the unhealthy states so that you don't get the situation where your equipment is functioning poorly, but it doesn't get alarmed. Both of these problems are solved by allowing that dynamic limit to occur. How is the model created? The way we do it is we take historical data that you've recorded before, typically in your archive system, and create a neural network model for one of these parameters, taking into account the others that are measured on the device. So let's say you have 10 sensors installed on your machine. We take the first 9 measurements to compute a model for the 10th, and then place a confidence interval around that, compare the measurement of the 10th variable to the model of the 10th variable. If they differ significantly, you get an alarm. It's very simple, particularly because we use the machine learning methods to develop that model, so you, the human expert in your plant, don't need to worry about exactly how this works. You just give the data to the software, and the software does all the modeling and proves to you that the model is in fact accurate enough for this alarming system to work properly. The way that we can justify that this methodology works at all is because all of these various parameters during normal operations have a certain correlation relationship with each other that remains constant through different production conditions that are, however, all healthy operations, normal operations of that equipment. As soon as the equipment becomes unhealthy, usually due to some form of aging or damaging, then the operation, this correlation between these various measurements basically leaves the normal set of correlation behavior, and therefore you can see the difference between the model, which is basically a representation of that normal correlation behavior, and the actual measurement. So you see the two lines that used to be the same drifting apart, and as soon as the drift is larger than the confidence interval, then you get the alarm that it's an unhealthy state. An unhealthy state does not necessarily mean your piece of equipment or your plant gets a trip. It's actually an early warning sign that some kind of damage mechanism is operating, the machine is no longer in perfect working condition, and at that moment it would be the right time to go stop the piece of equipment and send somebody out to look at it. It's not yet broken. So this is the advanced form of condition monitoring. We call it the intelligent health monitor, based in our case on machine learning. You can look please on our website for more information regarding the product, regarding us, and some case studies that we've performed in real life industrial plants where you can see that this really works. To discover what kind of mathematical methods we employ, I've recently published a book called Optimization for Industrial Problems, in which you can read about all of the mathematical methods. We don't keep industry secrets. It's completely open there for you to see, alongside with a number of case studies. The case studies you will also find on our webpage, where you can read what we have done for concrete plants, and you will also see there individual people for whom we have done this, so you can go check what we have done. Thank you very much.